Okay, question 5 of 2019 OCR A Further Mechanics paper. It's a modelling question with differential equations. Kind of question you could potentially see on the pure part of the paper, I believe, because it really is only applying F equals MA, really. But anyway, it's on the mechanics part, so that's neither here nor there, really. But it's a modelling, and I suspect there's going to be lots of these types of questions in coming years. So the first bit is about setting up the differential equation, and because it says show that, we need to make sure we do exactly what that, we show it and we explain our work. So it says a constant force of magnitude F is moved in a positive direction. So it's moved, something's free to move along the x-axis. Let's just draw my x-axis here. And we've got the particle P here. And the forces on it are F going in a positive direction. This is obviously positive this way. And there's a resistance force R, which is proportional to the speed, capital R, which is proportional to the speed, going that way. So we're going to be applying F equals MA. Okay, so we're told some information here about the fact that it's proportional, and also that when R equals 2, V equals 5. So we've got R is proportional to V, or the magnitude of R is proportional to V, or R equals to KV. So therefore we can say that we can sub in the appropriate values, so that's 2 equals K5, so K equals 0.4. Right, so now what we do is we apply F equals MA. And it is important, because it's so that the mark scheme says, must be clear that it's from F equals MA. And the easiest way to be clear is to write F equals MA. So we're applying F equals MA. In the positive direction we've got the F, in the negative direction we've got R, equals to mass, which is 4.5 kilograms, times by acceleration, and because the thing's in terms of V, let's write it as dV by dt. So we know that R is equal to K times V, so that's 0.4 V times 4.5 dV by dt. Right, so now let's just times through by 10. So we have 10F minus 4V equals 45 dV by dt. So we have dV by dt is equal to 10F minus 4V over 45 as required. Part B, we go on to solve and interpret the solution for this. So we're separating the variables for this equation. So we can write integral of 1 over 10F minus 4V dV is integral of 1 over 45 dt. Okay, so we can integrate both of those bits. Don't forget the constant. So that's because of the minus 4 here, and we're integrating with respect to dV, we're going to have a minus a quarter. We need to divide by ln 10F minus 4V is equal to 1 over 45t plus c. Okay, so what we can do here now is we can, before I move on, you might be thinking, shouldn't I put a modular sign here? Probably, strictly speaking, should, because we don't know whether V, and we'll see this in the modelling part, whether V is greater than 10F or whether 4V is greater than 10F or not, and that will affect whether this is positive or not. But it all comes out in the wash, and generally with mechanics questions of a practical type, getting bogged down with the modular sign is not necessary because it's not pure maths. But if it were a pure maths problem, we probably ought to explain why the modular sign, what's happening with the modular sign, but we don't need to here. Okay, right, so let's manipulate this a bit. So we can say that when t equals to 0, v is equal to u. So that gives us that, because if we put 0 into that just means that c is equal to minus 1 over 4 ln 10f minus 4v. Okay, so let's put the c back in. So we get minus a quarter ln 10f minus 4v is equal to 1 over 45t minus 1 over 4 ln 10f minus 4v. Okay, let's just change the signs and times through by 4 here. So we'll have ln 10f minus 4v is equal to minus 4 over 45, and notice the minus 4 out of 45 does appear in the in the final answer. It's a good idea to kind of have an idea where we're heading to. Plus, and then that's going to be ln 10f minus 4v. 4u, sorry, I should have written u there and u here. U. Okay, so 10f minus 4u. So let's now e it, I suppose. So we've got 10f minus 4v is equal to e to the minus 4 over 45t plus ln 10f minus 4u. So that's obviously equal to 10f minus 4u bracketed times by e to the minus 4 over 45t. So we can begin to see we're getting close to this answer here. Let's rearrange this a bit and divide through by 4. So we'll have v equals to 10 over 4, that's 5 over 2f. Then we would have this bit here would be negative, this bit here would come to the other side of the equation, so that would be minus 5 over 2f e to the minus 4 over 45t, and then this bit here would be divided through by 4 would be equal to u plus u e to the minus 4 over 45t. And just taking out, again looking at our final answer, well, I think we're okay to write it here. We can see we've got the 5 over 2t, 5 over 2f there. We can see we've got the minus 5 over 2f here with the final answer. And we've got the plus u as well. So I don't think we have to, we've done all the hard work. I think it's okay to just write the answer down now. So as v is equal to half bracket 5f minus bracket 5f minus 2u e to the minus 4 over 45t. Okay, so now moving to the second part. There's a reason why it's got us to write it in this particular form, because it wants us to look at three different cases here. And actually, going back to the original, I mentioned something about the modular sign with the differential equations. It does make a difference what's happening where, if u is if the initial velocity is of a particular value where the quantity 10f minus 4v is positive or negative, and that's where all that modular sign kind of comes into play if you were to do it in a pure mathematical way. But we've got the final equation now, and we just need to look at the different scenarios that occur. I might do the middle one first because that's the simplest, because of course if 5f minus 2u is equal to 0, so if we've got u equals to, right, second part, if we've got u equals to 2.5f, then of course that means that 5f equals to 2u. So the graph of it, if we were to draw it in that way, because this bit would then be 0, so the velocity would be constant. Okay, and it would actually be equal to 5 over 2f, but it would also be equal to u. So it would just be constant on u, or 2.5f, which is u. Okay, so that's the kind of the case when it's bang on the value here, these two, where 10f is exactly equal to 4u or 4v. So there, in this case, we would just say velocity constant at u, which is equal to 2.5f. So that's the case if u is equal to 2.5f, which was the middle one. Right, now for the other two, what we need to actually look at is, and it's the reason why it's written in this case, is this particular quantity. Notice the negative sign here as well. The key to the idea here is as t tends to infinity, e to the minus 4 over 45 t tends towards 0. So now if we have the case where, let's just consider the second case, u is less than 2.5f, okay, then the equation here, remembering that this quantity here would be positive, would become v is equal to half 5f minus some constant e to the minus 4 over 45t, where k is greater than 0. So it's basically, in that case, what's going to happen is the velocity is going to be you're going to have a case here where we've got the initial velocity u, and it's going to be increasing towards the value minus 4 to 45t. So it's going to be increasing to the quantity here, which will be equal to, as t tends towards infinity, this tends towards 0, so it increases towards 5 over 2f. Okay, it increases because this will have its maximum value when t is equal to 0. Okay, it'll have its maximum value when t is equal to 0, and actually just becomes, you're taking it away, and it becomes less and less and less. So it increases towards the quantity 5 over 2f. So we better write that in words. I know there's only 3 marks, but we need to make sure we get them. Velocity increases towards 5 over 2f. Okay, now if u is greater than 2.5f, now we've looked at that case, that basically then you've got the opposite case. We've got an asymptote 5 over 2f here, and we've got the u here, 5 over 2f, so the velocity decreases towards 5 over 2f. Okay, so the final part is just looking at a particular case. I've brought up the question again here. We're on part C now, and we now told that u is equal to 5f. So we can put that into our expression that we've found. That's probably the first thing to do. So when u equals to 2f, we've got v is equal to a half times by 5f, and put in u is equal to 2f into there, we'll get minus f e to the minus 4 over 45 t. So now it just becomes a differential equation because it wants the displacement when t equals to 9 in terms of f. So we can integrate both sides of this, and we can say that x is equal to, because remember v is equal to dx by dt. Okay, so we v is equal to half 5f minus f e to the minus 4 over 45 t dt. So that integrated, well, this is just a constant here, that bit. So that's half, or 5 over 2f t. And this we just have to divide by the constant in front of there. So that's divided by minus 4 over 45, which has the effect of changing the sign. As for, and then we've still got a half there, don't forget. So that's going to come to 45 over 8 f e to the minus 4 over 45 t plus c. Don't forget the constant. If you do, you'll get it wrong, because even though when t, we're told effectively when t equals to 0, x is equal to 0, early on in the question, I think. Yeah, here. But even though that is the case, it's not the case that the constant is 0. So when t equals to 0, x equals to 0. So that comes to 0, that's 0. But of course this bit will be equal to 1. So that tells us that c is equal to minus 45 over 8 f. So now it's just a case of putting in t equals to 9 into here. So we've got x is equal to, this bit will come to 45 over 2f. This bit here will be 45 over 8f, but the inside, because we've got 9 inside there, that will be e to the minus 4 over 5. And this bit here is constant. Okay, so put in over a common denominator of 3 times in this by 4 on top and bottom. That one taking out 45 over 8 as a common factor, and f, we'll get 45 over 8f is equal to 4 plus 45 plus e to the minus 4 over 5 minus 1, obviously, so then that comes to 45 over 8f 3 plus e to the minus 4 over 5, and it did want his exact. Okay, that's it.